Guided practice 3. The random variable x has a probability density function f given by this piecewise function, where k is a positive constant. State the mode of x. We are looking for x equals c, where f of x is at a maximum. Let's talk about inverse trig function. Let's use this diagram to remember the domain and range of inverse function. Inverse cosine, inverse sine, inverse tangent. Let's label the range. Range will be the angle 0, pi, negative pi over 2, pi over 2. For inverse sine and cosine, the domain is from -1 to 1. For inverse tangent function, domain is all real numbers. For sine function, domain is all real numbers. Range is from -1 to 1. Inverse sine, domain is from -1 to 1. Range is from negative pi over 2 to pi over 2. For cosine function, domain is all real numbers. Range is from -1 to 1. Inverse cosine x, domain is from -1 to 1. Range is from 0 to pi. For tangent x, domain is x not equal to pi over 2 plus k pi. K is all integers. Range is all real numbers. Therefore, for inverse tangent x, domain is all real numbers. Range is negative pi over 2 to pi over 2. For example, let's compare these two inverse functions. Inverse cosine of negative square root of 2 over 2 equals, this go to the second quadrant. So we get 3 pi over 4. For inverse sine of negative square root of 2 over 2, go to fourth quadrant. Answer will be negative pi over n, which is negative pi over 4. Now let's go back to this question. We need to check when x equals what value? F of x is at a maximum. Pi minus arc sine, since domain is between 0 and 1, we know arc sine is from 0 to pi over 2. We are looking for the maximum value. When x equals 0, pi minus arc sine has a maximum value. Therefore, x equals 0 is the mode. Let's go over tabular method. When calculating the integral of the product of any two functions below, we will use tabular method. The priority to change it into integral will be in this order. Here is the tabular method, how to write down your answer. Integral of f of x, g of x, dx. We use the tabular method to get this. Then here's the way to write down your answer. Positive sign, f of x times a minus f prime of x times b plus f double prime of x times c minus integral. Horizontal line go to integral. Third derivative of f of x times c dx. Therefore, for integral of arc sin x dx, consider this as 1 times arc sin of x. S di, sin derivative integral. This sign will be positive or negative. Derivative arc sin x. Derivative of arc sin x will be 1 over square root 1 minus x squared. Integral is 1. Integral of 1 is x. We will write down answer like this, equals x times arc sin x, then minus integral x over square root 1 minus x squared dx. Since 1 minus x squared prime equals negative 2x, we have x here. We will use reverse chain rule. Integral x square root 1 minus x squared dx equals integral. Change denominator as a single power, negative 1/2 times negative 2x, then times negative 1 over 2 dx. We will use this formula, integral u to the nth power times u prime dx equals u to the power of n plus 1 over n plus 1 plus c. U is 1 minus x squared. This is u prime. So we get 1 minus x squared. Negative 1/2 plus 1 is 1/2 over 1/2 times negative 1/2 plus c, reduce. We got negative square root 1 minus x squared plus c. So we get x arc sin x minus negative square root 1 minus x squared plus c. Simplify x times arc sin x plus square root 1 minus x squared plus c. Let's go to c. Hence, show that k equals 2 over 2 plus pi. We will use this formula, integral from negative infinity to positive infinity of f of x dx equals 1. So we get integral from 0 to 1 of k times pi minus arc sin x dx equals 1. We will take a k out. Then we got pi x minus integral of inverse sin x dx equals this. We already got this from problem B. So minus parentheses x arc sin x plus square root 1 minus x squared. Evaluated from 0 to 1 equals 1. We do distributive property here. K times pi x minus x arc sin x minus square root 1 minus x squared evaluated from 0 to 1 equals 1. Then we will substitute 1 into these expressions. K times pi minus arc sin 1 is pi over 2 minus 0. Then remember, here is a minus parentheses. Substitute 0 into these expressions. 0, 0, negative 1 equals 1. K times pi over 2. Negative, negative is a positive. Plus 1 equals 1. K times pi plus 2 over 2 equals 1. So K equals 2 over pi plus 2. Let's go to D. Given that y equals this, show that dy dx equals this. Dy dx equals derivative of this, we got to do product rule. So we get x squared over 2 prime times arc sin x plus x squared over 2 times arc sin x prime minus derivative of this 1 over 4, 1 over square root 1 minus x squared. Derivative for this, we got to do product rule again, plus x over 4 prime square root 1 minus x squared plus x over 4 times square root 1 minus x squared prime. So we get 2x over 2 is x times arc sin x plus x squared over 2 times 1 over square root 1 minus x squared minus 1 over 4 square root 1 minus x squared plus 1 over 4 times square root 1 minus x squared plus x over 4 times 1 minus x squared to the 1/2 power prime. We got 1/2 times 1 minus x squared to the power of negative 1/2. Don't forget the chain rule, negative 2x. So we reduce. So we get negative x times 1 over square root 1 minus x squared equals x arc sin x plus x squared over 2 square root 1 minus x squared minus 1 over 4 square root 1 minus x squared plus square root 1 minus x squared over 4 minus denominator is 4 square root 1 minus x squared. Numerator is x squared equals x arc sine x. We will get the same denominator plus 4 square root 1 minus x squared times 2 times 2. We got 2x squared minus 1 plus times square root 1 minus x squared to the numerator and denominator plus 1 minus x squared, then minus x squared. We got 0, so we get x arc sine x. Let's go to e. E of x, which means expected value, equals 3 pi over 4 times pi plus 2. We are given f of x equals 2 over pi plus 2 times pi minus arc sine x. For x greater than equal to 0, less than equal to 1. So e of x equals integral from 0 to 1 of x times f of x dx. Do the substitution, integral from 0 to 1, x times 2 over pi plus 2 times pi minus arc sine x dx. We will take 2 over pi plus 2 out. Integral from 0 to 1. Do the distributive property pi x minus x times arc sine x dx equals 2 over pi plus 2. Take out pi x will be pi times x squared over 2. Then minus. Let's go back to question D. Since dy dx equals this, integral of x arc sine x dx equals this plus c. Minus, we got to change the sign. So x squared over 2 arc sine x plus 1 over 4 arc sine x minus x over 4 square root 1 minus x squared, evaluated from 0 to 1, equals 2 over pi plus 2. We will substitute 1 to these expressions. Pi over 2 minus 1 over 2 arc sine 1 equals pi over 2 times pi over 2 plus 1 over 4 times pi over 2. Then minus 1 minus 1 is 0. Then remember, subtract, parentheses, substitute 0 for x, 0, 0, 0, all 0. So we get 2 over pi plus 2 times pi over 2 minus pi over 4 plus pi over 8. 8 is LCD, so times 2 times 4 equals 2 over pi plus 2 times 4 pi minus 2 pi, then plus pi, 3 pi over 8. Reduce. We got 4 times pi plus 2 as a denominator. Numerator is 3 pi.